first automatic mode of jewelry cam we'll discuss is the wedding band type rings. All that is meant by wedding band is a band ring which has some sort of engraving or text or formation on the flat side of the shank and possibly on the inside of the shank as well, but nothing on the top or the bottom sides. So let's say you bring in a ring or you create one rhino. First thing you need to think about is how do you position the ring so that it is corresponding to the wax stock that you'll position in your mill. The easiest way to check that is by going through the initial steps in Jewelry Cam and seeing the preview that the program gives you. So we selected our ring, we click wedding band geometry type and click select geometry button. We're prompted to select any additional geometry if in case that there's more than one piece, and when we're finished press enter, and then we're asked to select a support. Supports are little segments that will hold your finished product to the wax stock. So that's the part that will not be cut off. It's your connection to the original wax block, and that's what's basically keeping your ring from falling down once you have finished your milling job or once you've cut off enough of the wax around it. In case of wedding bands or bands in general, Jewelry Cam is able to operate without supports, and I will show you how that is possible. But the trick is to position it properly within the world of the mill itself. So when asked to select the support, just press enter and observe the preview that the Jewelry Cam gives us. This is our chuck of our imaginary mill, and as you can imagine, you have this wax block jutting out from it. The key thing is to have our ring, our band ring, positioned in parallel with this chuck as you see it right now. So it's as if it's stuck within a cylindrical wax block. If this is laid out in the proper way, then we will get our geometry parameters window as you see here on the right, and we're able to press apply button to make this little preview go away. And right away we will see that Jewelry Cam starts adding toolpaths to our operation window. This is done completely automatically. But let's take a step back for a moment and see what happens if we had this ring positioned in a different way. First of all, when you move your geometry or rotate it after you have created your operations, Jewelry Cam will warn you that this will reset your workflow because obviously it will no longer be valid. So, do we wish to proceed? Yes, we do. The operation list is cleared. So, let's say we come in with our ring position this way. Now, we select the same ring, click on the wedding band, select geometry, and press enter. We're asked to select the supports as before. And well, now we get this warning from Jewelry Cam that it's unable to retrieve ring parameters. When you get the screen, check your positioning. Your ring needs to lie flat on the C-plane that represents your X and Y vertices. So Z is pointing up, X and Y are your plane vertices. This is the correct way. Whether your ring is upside down as you see it right now or correct side up doesn't really matter. It will mill out either way, but it's important that it's lying flat on this construction plane. So once again, click on wedding band, select geometry, press enter, and press enter, skipping the supports again. Now we're given this preview, and here, before we move along, we should make sure that we correctly define our stock material. Jewelry Cam uses stock material to avoid crashing into your uncut stock while it's milling. So, for example, if you have your standard large wax cylinder, which is approximately 32 mil in diameter or 16 millimeters in radius. Make sure you put 16. To enlarge it and make sure that the bit and all the operations moving around will not crash right through it or try to cut through it. Likewise, if you're going to have your ring jutting out here, or if you're going to have a wax stock that's going to be longer than this, make sure you specify it. Otherwise, once again, you risk driving your tool bit into the wax stock. Give yourself some extra room if you have to. Click apply, and you will see operation definitions automatically added to operations list. We have everything from the trim to ejecting waste to finally finishing the ring. When you see these stop signs or crossed out signs, it means the tool paths are defined and added but not calculated. This is how JewelryCam keeps the Rhino file size small. It simply gives the toolpath definitions but doesn't calculate them until asked. So, two ways to calculate the toolpath. You can either click on this little cycle icon like this, and this red icon will change into a blue check mark. Or you can click somewhere inside of this little window and press Ctrl F5 to calculate all of the toolpaths, and you'll see the little progress bars go. You can stop them with a little crossed out sign, or you can wait until they're finished. As you can see here, that was a pretty quick calculation, and our toolpath set is calculated. We can now go to our simulation window. As you recall, we do that by clicking this mill button. We're brought into a different window, and now our toolpaths are visible here, our stock is visible here, and actually there's a way to show our piece within the stock as well. So let's do that first. Here up top, we can define whether the stock, their initial geometry, is visible, transparent, or hidden. I prefer to use transparent. It allows me to see into the piece, but it still shows me the outline of the overall stock. For the workpiece, by default it's hidden, but I like to show it. This gives me an idea of where my final model will be once everything is cut out. Beyond that, there's a few other controls that are very useful and you'll be using them all the time. Obviously, the run, stop, fast forward, step back, the usual operational controls, simulation speed, and the machine mode versus workpiece stock mode. So you can switch between one and the other. This is really simply to get better view of your toolpath operations as they work. So let's start the simulation and we'll switch around and we'll show you what the differences are. Press run, and you can see the first operation will trim off the excess wax stock, and then it will continue to do the other ones. So here we are removing the excess wax stock by cutting around the outside. And right away you can see this is a true 5-axis or more operation based program, because we're not cutting at a 90-degree angle, we're cutting at a 95-degree angle, meaning that these lines are flat. With these cuts that we're making are intentionally at an angle so that our walls are flat. As this is cutting, let's go to a slightly different view. So we'll go to our workpiece / stock view. This allows us to keep our view constant and have the tool bit move around. Pretty handy when you want to just focus on one particular part, let's say just these letters on here. Finally, we can switch to the tool mode. This keeps the tool constant around the view and moves the stock. Once again, different perspective on things. Before we leave this window, I want to draw your attention to not just the move list and the individual moves, which you can see switching here, but
the Statistics tab. A very useful set of information is contained here, including your minimum and maximum for your toolpath, as well as giving you an estimate of how long the overall sequence of all of your toolpaths will take. In this case, for example, saying 4 minutes, 53 seconds. If at any time you want to stop simulation, you can just close this window. You can also rewind it, go back to specific moves to replay them, and use it to preview and make sure that you are doing what you're expecting to be doing. So let's close this and go back to our operations list. When you click on individual operations, you'll see that each one will have different settings. Almost all of them will feature feed rates. This is your speed control, how quickly you will run, how quickly you will move your tool bit across your wax. But in addition, different strategies reflected in different tool paths will give you different settings. So for example, this trimming will give you an option to have a little bit of an offset to your cut, so it's not flush with the ring, but giving you a little bit of a skin around it, as well as how many revolutions you make around it. Inside cut gives you a number of revolutions. Ejection of the inside waste, which is really just a little push of the wax, gives you no choices except for speeds. Rough operation gives you, once again, number of revolutions. And once you get to the finishing operations, which are your really the key operations, these are the ones that do proper cuts. Here you get a few more options. Notice that we have two finishing operations. We have finish inside and finish outside. So let's look at the finish outside first. You'll see that here we have these vertical lines, and they are step over size apart, in this case 0.5 millimeter apart, which is pretty rough in terms of getting any fine design on the ring. So let's switch it to 0.05 and click apply. And to recalculate, we'll press our style calculation button. And now we see that our lines are much closer together. So if you unselect that particular operation, you'll see that the color of the toolpath changes as it goes. So it goes from dark blue at the start, and as it goes around towards the end of the toolpath, it changes to a very light blue. So at this resolution, we will capture fine details like the text. For the inside of the ring, you'll see our toolpaths are going horizontally, and you can see this reflected here in the settings. We can choose to have either horizontal or vertical cut and a step over size. For the inside, unless you have an engraving, you can choose a rougher step over size and still get away with it just fine. Let's see how that looks. So that looks quite reasonable. And in addition, we have options for how this inside is cut out. So right now it's set on the 5-axis mode and a maximum tilt of 45 degrees, meaning that the ring can tilt all the way up to 45-degree position away from horizontal in order to capture all of these details. You can also leave it on max auto detect, which will try to capture all of your details and potentially go beyond this angle. I recommend leaving this as is until you're more comfortable with it. Finally, our trim up at the bottom is this great feature of Jewelry Cam that allows you to mill out these kind of band rings without any supports. What it will do is it will position the bit at the bottom, at the back of your ring if you will, and will make a nice cut with the side of the tool to cut off this flat surface and remove it from your wax stock. You're given an option for an offset, which I wouldn't recommend because you generally don't need to offset it that much. And in addition, you can specify the number of revolutions to make. But once again, after the first revolve, your ring, if all goes well, should come off, and a second revolve is simply not necessary. So, as you can see, even though this video took a little longer to explain, it's a very fast operation. This overall setup for a band ring, you just have to make sure you position it correctly. You select the wedding band and you do not select any supports. They're not really necessary here. Then you make sure all of your toolpaths are calculated. You double check your finish quality in terms of your step over inside and outside. And make sure, as always, to confirm that what you wanted to have happen is happening in the simulator. Now that you're happy with your toolpaths, you can generate them into an NC file by clicking the NC button and giving it a name. In the next tutorial, we will cover slightly more complex engagement type rings.